going to give you a short overview of the Event System Configurator in Atmel Start, the event system which is used for peripheral-to-peripheral signaling in AVR and SAM microcontrollers. So we're going to first cover the principles of configuration and how this works in general, and then we're going to go through a simple use case where we generate an event on a button press, feeding this out on the GPIO, on the PINMUX, and then similarly configure a periodic interrupt timer and generate an event at a specific time frequency.
I'm going to create a new project for the 80x8.7 X-Plane Pro and add the event system component as well as the RTC. So once we add the event system, we can click on the event system in the project dashboard and you get a fairly low-level configuration here. But you also get an events tab, which is a more graphical user interface, and this is our focus here. So I'm wanting to show some general principles. Generators, so these are peripheral generated triggers, which are then connected to peripheral users of events, and it's a kind of wiring together of these different things. So as we start clicking on one of these generators, we can see which channels it's possible to connect this to. For instance, here with the RTC, some of them have multiple options and some are more specific in terms of the channels that's supported. The first principle is that as you have a particular channel, there's only one event trigger which can be connected to it. So if I take the overflow and now I take the timer compare, I connect it to the same channel, and you can see that this counter compare has now overwritten that connection because the channel can only have one trigger. But we can take the same trigger and connect it to various channels, and we are able to take a channel and connect it as well to various users. And to emphasize this, I can add another component directly here, glue logic. And notice that here this is both an event generator from the logic and it's also an event user, so we can connect in this way. We are able to reset to device defaults, and if we had an example project out open, it would give us the option of resetting to the project defaults. So we're going to reset this now. I'm going to go to the dashboard and remove the digital logic component. And now I'm going to set up a basic use case. What we're going to do is have an event on PV5, which happens to be the push button on our kit, and this button is asynchronous to the device main clock, and so that's why it's connected to an asynchronous event channel. So now I'm going to see that I can output this on the PINMUX, which enables us to connect to actual GPIO pins. And likewise on the RTC, I'm going to later set up a clock of 1 kHz on the RTC, and then I'm going to have a periodic clock divisor there as well of just 512, so that's going to give us an output of 2 Hz, connecting that to output 1. So just checking that RTC clock, you can see it's currently set up as 32 kHz, so we're going to choose a 32 divided by 32 clock, and here you can see we have a 1 kHz output. Okay, on the PINMUX side, we must just set up PB5 as an input, so this is switch 0, and we're going to set this up as a digital input, and we need pull-ups. So I need to enable the PTC, and in the event system I need to enable the output pins and export this project. Drag it onto Atmel Studio. Note that on the 817X Pro, 57 is the number of the embedded debugger. So I'm just going to select that and program the part. And then I happen to be using a 4809 just because of the DGI GPIO. So in the data visualizer, I'm going to connect to the 4809. And use 2 of these DGI GPIO channels, drop them onto a graph. I can see now that I have some output and spacebar to stop. I can enable the cursors, can change the color. I can see that I have a 2 Hz output as expected, and if I start pushing the button, I can see that I'm getting signals out on the event system directly related to those asynchronous events.